Good morning, everyone. My name is Hayden. I represent 1/5 of Suave Inc. I'm joined here today with my esteemed colleagues Ash, Dave, Ben, and Diane. We're all mechanical engineers in 4th year, with the exception of Diane, who's our resident chemical engineer. And Suave Inc., it stands for Sophisticated Unmanned Aerial Vehicle Engineering. So we deal with unmanned aerial vehicles, or UAVs, and to kind of put that in a nutshell, we're talking about aircraft that fly without people on board. So the quintessential example of the UAV is the Predator aircraft from the United States Air Force. Now this is an aircraft that's only been in use since 1995, and it flies up. It's been flying above the Middle East for some time now. It lasts 14 hours, and it's got, as you can see, like all the surveillance equipment at the front. So it's used primarily for surveillance, but it also has those 2 massive missiles there as well. Anti-tank missiles for taking out, obviously, tanks, villages, whatever the Air Force deem appropriate. But also we have things like helicopters. UAVs can be made into any kind of conventional aircraft that we know. So just a quick summary. We're dealing with remote or autonomous aircraft. And these UAVs can take on all the forms of conventional aircraft, but they're also not really limited by size. They need to be only as big enough to house the instrumentation and the fuel that they need for whatever purpose they're for. And obviously, from the examples I've given you, they're a favour of the military, but here at Suave, we're more of a civilian company. We're not so much interested in killing people. So we're looking at some of the civilian uses, and there are a plethora of uses. And the bigger font there is some of the more prominent one, like search and rescue, scientific research, basically anywhere with a large area that needs to be surveyed with some kind of instrumentation. But with all those uses, you'd consider you'd wonder why we don't see them already. And here at Suave, we think that's due to 2 main things. First, we think that takeoff is far too complex. At the moment, with a smaller, cheaper aircraft, someone actually needs to be there with a remote control, taking care of the takeoff process from start to finish. But probably a more significant issue would be the fact that ideal runways are far too hard to come by. For example, if we wanted to do some traffic surveying in New York City, how are we going to find a runway for that? If we wanted to rescue people with a UAV off Bondi Beach, the sand is far too soft, there's far too many people on the beach. And if we wanted to try and find illegal fishing boats or illegal immigrants, we can't launch a boat, there's just not a runway. So very, very recently, the answer to this problem has been in the form of a UAV launcher. And there's one from the military there, very kind of recent technology. And basically this allows for a launch anywhere solution. So we need only a couple of square meters free, and we can go from being docked to achieving flight underneath a second. So yeah, it simplifies takeoff procedure substantially. But also, we can also simplify the aircraft design itself. We don't need to reinforce landing gear. We don't even need to have landing gear. So brings me to the Suave launch. Now we'll be launching this lovely aircraft called Penelope. It's quite large. It's maybe from myself to Ash long, so it's quite large. And we're going to tailor this to Australian surf lifesaving, with the initial hope that by October we can do a proof of concept. We can launch this aircraft rather, out over the ocean, and it can drop a life raft to someone who is in a distress situation. It'll be a mock exercise, obviously, and we think that the technology that we develop will be very expandable to other industries. So we think that the minerals industry, that the fisheries and forestry will rely on effectively the same kind of design. And we're hoping to grab our funding through our sponsorship from companies willing to lend their names to a good cause, such as saving people's lives. And that's a full aircraft right there. So with this in mind, our design goals are primarily to get as many UAV launches to as many people as possible. So we want it to be as low cost, easiest to set up, easiest to maintain, but because we're dealing with search and rescue, we want this to be the most reliable UAV launch that we can possibly have. We don't want people waiting for UAVs and not getting them when they need them most. We've considered a fair few technologies. We've considered things like electromagnets, counterweights, pneumatic compressed air, and rockets and whatnot. But we think by far that the elastic impulse technology is going to work best for us. It's very rudimentary. It's effectively a large rubber band. It's going to slingshot an aircraft, but it's by far the simplest, lightest, cheapest, and easiest to maintain. And achieving this, is not be as easy as just flinging an aircraft off a launch pad. There's going to be a substantial engineering involved in designing a structurally efficient, spatially efficient structure itself. We're going to have to look at how to reinforce the UAV to deal with massive forces coming from the rear, and we're going to have a massive kind of analysis of the ideal accelerations, velocities, and launch angles that we're going to need to achieve the flight. And obviously we're going to have to select the best material as well. And once we've done all that, we have to exhaustively test our model. Now we do have a model here today. It's what we've kind of knocked up in the last couple of weeks. It's not the final model. We were kind of hoping to test it, but OH&S would really not approve of that. It's far too powerful at the moment. So yeah, no demonstration today, unfortunately. So just a quick timeline. Today we're releasing our initial concept. Our final concept of business model should be done by end of next month, and then next semester we'll be looking at the final design reviews and business plans, and in October we should have the proof of concept and something rather final taken care of. So that's it. We're pretty excited about it. Hope you guys are slightly excited about it as well. And we'll be taking your questions now.